The function, which converts nautical miles, statute miles, and kilometers, utilizes the blue indices labeled naut-m and stat-m, and the red index labeled km, m, and LTR on the outer scale. An example will illustrate how the computer works. Let's convert 65 nautical miles to both statute miles and kilometers. As always, it helps enormously to get an idea of the magnitude of the answers before we start to manipulate the computer. A statute mile is a bit shorter than a nautical mile, so the answer to the first conversion will be a figure just greater than 65, while a nautical mile is almost 2 kilometers, so we'll be looking for almost 130 kilometers in that case. Initially, place 65 on the inner scale under the blue naut-m index marker on the outer scale. We would advise that full use of the cursor is necessary for accuracy of alignment in this particular exercise. Move the cursor over the stat-m index marker on the outer scale and read off 75 on the inner scale. Our rough answer puts us in the region of greater than 65, so our answer is 75 statute miles. Leaving the inner and outer scales in the same relative position, move the cursor over the red km, m, LTR index. Read off 12 under the cursor. Our rough answer led us to expect something near 130, so our answer is 120 kilometers. The indices for the function of converting meters, yards, and feet are labeled on the outer scale in blue against the words yards and feet, and red against km, m, LTR. Once again, we'll use an example to show what we mean. Convert 1500 meters into yards and feet. A meter is a bit larger than a yard, so the number of yards is going to be very similar to the number of meters. On the other hand, the number of feet in 1500 meters is going to be more than 3 times as great. First, place 15, representing the 1500 meters, on the inner scale under the km, m, LTR index on the outer scale. Moving the cursor over the yards index, read off the figure 16.4. Our approximate answer tells us that 1500 meters equals 1640 yards. Now, still maintaining the relative positions of the inner and outer scales, move the cursor over the feet index and read off 49.2. Our rough calculation tells us that the number of feet in 1500 meters is 4,920. Blue indices against kg and lb labels on the outer scale, representing kilograms and pounds, allow weight conversions to be made. To illustrate, here's an example. Convert 2,700 pounds into kilograms. To get a rough idea of the magnitude of the answer, we could use the old saw that states 2 1/4 pounds of jam is equal to a kilogram. Using mental arithmetic, divide 2,700 by 2 1/4. This gives us an answer in excess of 1,000 kilograms. Now set 27, representing 2,700, on the inner scale against the pound index on the outer scale, using the cursor for accuracy. Then rotate the cursor to align it with the kg index on the outer scale, and read off 12.3 from the inner scale. The order of magnitude we arrived at by using mental arithmetic indicates to us that the answer is 1,230 kilograms. Capacity conversions involve our converting between imperial gallons, US gallons, and liters. The function that enables us to convert capacity utilizes orange indices labeled impgal and USgal, and the red index labeled km, m, LTR on the outer scale. Here's an example which should assist you in understanding the method used. Convert 190 imperial gallons to both US gallons and litres. In order to work out a rough conversion factor, you should bear in mind that the US gallon is slightly smaller than the imperial gallon. As a rough guide, we can say 1.9 imperial gallons equals 2 US gallons. A given quantity of fluid, therefore, will be expressed as consisting of slightly more US gallons than imperial gallons. An imperial gallon contains about 4.5 litres, and a US gallon about 3.5 litres. Rotate the inner scale so that 19, representing 190 imperial gallons, is aligned with the imp-gal index on the outer scale. Setting the cursor over the US gallons index, we can read off a figure of 22.8. Our rough calculation indicates that the answer will be 228 US gallons. Ensuring that the inner and outer scales remain in their relative positions, move the cursor until it's superimposed over the red km/m LTR index and read off 86.5. Our rough calculation indicates that the answer will be 865 litres. There are two blue scales on the periphery of the instrument which enable us to convert volume into weight and vice versa. They're labelled SPG, which stands for specific gravity. The first scale is used to convert pounds of fuel at various specific gravities to imperial gallons, US gallons, and litres, and vice versa. This scale can be identified by the blue letters LB adjacent to it. The other scale is used to convert kilograms of fuel at various specific gravities to imperial gallons, US gallons, and litres, and vice versa. This scale can be identified by the blue letters kg adjacent to it. An example will help you get an idea of how to use this function. Find the weight of 44 imperial gallons of aviation gasoline at a specific gravity of 0.72 in both pounds and kilograms. As usual, we have to get an estimate of the magnitude of the answers before starting to use the navigation computer. An imperial gallon of gasoline weighs 7 pounds. Therefore, 40 imperial gallons should weigh 280 pounds. Remembering from a previous example that 2¼ pounds is roughly equivalent to 1 kilogram, it follows that 280 pounds is going to be roughly 100 kilograms. Using the cursor, place 44 on the inner scale, under the imperial gallons index on the outer scale. Move the cursor so that it's aligned with 0.72 on the pounds SPG scale, and read off 31.7 on the inner scale. Our estimated figure tells us that the accurate answer is 317 pounds. An identical procedure, but using the US gal index instead of the imp gal index, will enable us to convert US gallons into pounds. Ensuring that the scales remain in their relative positions, move the cursor to align it with the 0.72 on the kilograms SPG scale. This is fairly straightforward if you use the graduations on the outer scale, which are exactly the same value. Read off the figure under the cursor, which is 14.4. Taking into account what our rough estimate told us, the weight of the fuel in kilograms is 144. Now for an example of how to convert a weight into a volume. As we always do, let's use an example to demonstrate how this function works. Convert 210 pounds of aviation gasoline at a specific gravity of 0.72 into imperial gallons, US gallons, and litres. We need a rough idea of the answers before we start. Every imperial gallon will weigh about 7 pounds, and 7 goes into 210 30 times, so the answer will be in the region of 30 imperial gallons. Roughly the same will apply for the US gallon. 1 litre of fuel at the same specific gravity weighs about 1.5 pounds, so 210 pounds is the approximate equivalent of 140 litres. Initially, place the cursor over the 0.72 position on the blue pounds SPG scale. Then rotate the inner scale to place 21, representing 210 pounds, under the cursor. Keeping the inner and outer scales in their same relative position, move the cursor over the orange imperial gallons index on the outer scale and read off 29.2 on the inner scale. Our rough working tells us that the answer will be exactly 29.2 imperial gallons. Once again, not moving the scales, move the cursor over the orange US Gal index and read off 35. This means that 210 pounds of gasoline at a specific gravity of 0.72 fills a volume of 35 US gallons. Still keeping the scales very firmly in their relative positions, move the cursor over the red km/m/LTR index on the outer scale and read off 13.25, which, according to our rough answer, means that 210 pounds of gasoline at a specific gravity of 0.72 fills a volume of 132.5 litres.